Oh, hello. This is my project, Seeking Leaks, and in this project I was trying to simulate the system of a leaking pipe using software. So in my project I built a physical model of a leaking pipe, and I also wrote some software for my simulation. In my physical model, which is down here, what I would do is I'd fill the top pipe with water, and then I'd leak it at a initial rate of 0.24 ounces per second. And then I'd record the level using this scale every 10 seconds. And by the level in a horizontal pipe, if the leak is on the bottom, then the water will come down as a surface of a plane. And so to write this in simulation, I started to think about some components I need. I realized that the level and the volume are not proportional. If you look at it from the side, let's say this is the surface of the water, and anything below it is the level of the water. And so this level might be the same as this level, but this area is less than this area. So if I were to multiply it by the length of the pipe, then this would still be less than this. So I needed to figure out a way to solve this, to compare the length, level, and the volume. So the way I would do this is I would draw a radius, which is always going to be the same, out to the surface of the water. And I would do this to both endpoints of the surface of the water. And then I'd have a central angle from the center of the circle going out to the surface. I'd bisect or cut in half that central angle. And because this is an isosceles triangle, I would get two right triangles. So now that I have two right triangles, I can use these ratios that are known as sine and cosine to get the length of this length and the length of this length. So the way I can do that is, due to angle-angle similarity, the ratio of different sides in any triangle, any right triangle with this angle, is going to have the same ratio of sides. Now, one ratio that I use is sine. Sine is the opposite divided by the hypotenuse, and the hypotenuse is just the longest side of the triangle. So I'd multiply the radius, which is the hypotenuse, by the sine of half of this central angle. And then I get the opposite side. I get this way, and that's half of the surface length. And then to get this way, from the surface to the center of the circle, I would take the cosine of half of this central angle and multiply by the radius to get this way. And then I would have my level. I could either add it to the radius or subtract it from the radius if it was past the halfway point to get the level. And then to get the volume, what I could do is I could subtract this sector from the full circle, and then add the area of these two triangles, and then multiply this area by the length of the pipe, and I'd get the volume of the rod. So the way my coding would work is I would do a map of all of the angles between 1 and 360 degrees for this central angle. And then I would calculate some data using sine and cosine to get this length and this length for any of those angles. And then I would get the volume and the level for all of these angles. And then I would get the volume simply by taking my leak rate and subtracting it from the volume that's already in the pipe. And I would find the closest volume to it and take its volume and its level to get an approximate end volume. And this actually worked pretty well. After I was done with my simulation, I took the level every 10 seconds, just like I did with my physical model, and I put it into a chart, a graph, and I realized, and I saw that the simulation is actually really close to the physical model. This blue line represents the simulation, and these other lines represent the simulation, the physical model. So, if we look at this, graph, we see the error between these two. And what I realized is the error was increasing over time, so something was happening. There must have been some other factor affecting it. So I thought about it for a while, and I realized that when the pipe starts leaking, there's more weight from the water pushing the water out. Or a physical term for this is head pressure, which is the force in newtons coming down at any height of the liquid. And to calculate the head pressure of a liquid, you can take the height of the liquid from its surface to its bottom point, and then you can divide that by the specific gravity of the fluid. And this happens to be, for water, 27.7. So I've already started adding head pressure to my simulation, and in the future I'd like to add different angles, as you're not always going to have a perfectly horizontal or perfectly vertical pipe. Also, I'd like to look into what causes a pipe to start leaking. So this has been my project. I hope you've enjoyed it.